So this one we already learned the idea about similar triangles, how to prove similar triangles. So we are going to progress to similar figures. So it can be different figures, it can be circle, it can be cone, it can be cylinder, it can be pentagon. So whatever is it. So we're going to explore the area ratio and the volume ratio. So there will be some concepts I'm going to introduce first. So all these concepts, okay, the first three concepts are related to similar triangles or figure. That means, right, the question must tell you that they are similar or you have proof that they are similar. So when two triangles or two other shapes, okay, square or circle, if they are similar, their length ratio will be the same. So length ratio means, right, if you compare the left over right, it will be the same as when you compare the base over base. So it can even be you compare the perimeter. So if you go and compare the perimeter, so I'm going to call this part P1, perimeter, then this part P2, they will also be in the same ratio. So as long as they are under the length category, so any length in a similar figure or triangle, okay, if you explore the respective corresponding length, they will be in the same ratio. So when you compare the area, so area is, so this is what we'll call area ratio. So this area ratio is the squaring of the length ratio. So you're going to square the length ratio. So of course, you can also be squaring the base ratio. Okay, so any length ratio that you can get. So later on, when we try to prove similar triangle, we got 3 length ratio. So every time we prove similar triangle, we got 3 length ratio. So we can take any of the length ratio to square. So that is like a formula. And another formula will be called the volume ratio. So if we compare the volume ratio, it will be the cube of the length ratio. So same thing, of course, you can cube the base ratio as well. So again, you can take any ratio and if any of the length ratio and go and cube it. So how do you remember it, right? You can remember it by the units of area. So the units of area is usually like centimeter square, meter square, or we usually don't use until kilometer square. So it can also be kilometer square. So for volume, right, usually the units is like centimeter cube, meter cube, kilometer cube. So you can engage your units to help you. So this one is like all formula. You treat it like a formula. So the items in the formula will be usually provided by the question, and you might end up just cross multiplying. Okay, so these 3 scenario, I will call this the area ratio formula. So this is called the area ratio formula. So this is called the length ratio formula. And then this one is called the volume ratio formula. These 3 formula is only applicable when it is similar. If it's not similar, then none of these apply. So in an exception case, we got something called common height triangle. So sometimes when the 2 triangles are not similar, so for example here, okay, you explore this blue triangle. and you explore the red triangle. Obviously, they are not similar because they don't have any angles. If you try to do a AA, right, it doesn't work. So they actually share a common height. So this blue triangle, right, then you may be thinking, then how does the blue triangle share a height? So this blue triangle is the kind that you learn in primary school, where the height is out of the triangle. And then this will be the base. So I'm applying this idea on the blue triangle. The red triangle is very obvious. This is the height. So you can try working out the area of ABC. So if I work out the area of ABC, I will be using this height. And the base is B1. So if you take a look, so this is the area of the blue triangle. If I do the area of the red triangle, I'll be using B2 as the height, as the base. My height is still H. Because it's a common height, you end up cancelling. Finally, I'm just left with the base ratio. So in this case, right, the area ratio is reduced to base ratio. There is no squaring here. There's no squaring because it's not similar. So it's just a case of similar, you square. If it's not similar, you have to take the base, and if it's common height, it has to be base ratio. So the common height triangle is one of the more difficult one. Okay, so if it's not similar, and if it's not similar, you should think of common height. So this is the concept of common height. If the question already says similar, you stay with this formula. So just don't get confused. It's similar or not similar. So when it is not similar, it might be common height. If it's not similar and not common height, then it will be something else already.